Welcome back. Today we have another power supply related video. In the past I have showed you how to make benchtop power supplies out of ATX power supplies from a computer. As you can see, there's one sitting there in the background, and then I have my fancy desktop unit that I put together. And I've also showed you some of these buck converters that come in different shapes and sizes. For example, the one that you're looking at here that's actually set for 9 volts is a 3 amp output buck converter that accepts a wide range of voltages. This particular one really isn't going to go higher than 12 volt input because that's what the power supply it's hooked to is connected to. But you can use the buttons here to set the current and the voltage that you want this thing to output. And a buck converter in this regard is very similar to how a regular switched mode power supply works, which is what this is. There are buck converters that are transformer based, where it's just a big transformer, and depending on what wires you tap off of depends on what voltages you get out of, and that's more of a linear type of situation. But we're talking today about these switched mode buck converters. And the idea of a buck converter is it takes a higher voltage and steps it down to a low voltage, and that's another way to call it a step down transformer or step down power supply. Now there's actually a boost converter which does the opposite. It steps up the voltage, and that's kind of what we're going with today's video. Now I don't have any boost converters, nor do I have any the step up converters, but I have a special one here today that's actually called a buck boost converter, which is this guy right here. Now that's actually another bucket converter you can see here. This one takes again a wide variety of voltages and steps it down to 5 volts for a USB output. But the buck boost converter does both drop a voltage and raise the voltage depending on which input you're giving it, and there's a lot of uses for these things. The only problem that I found with them so far, and it's not a major problem I guess, but it kind of is there's no suppliers that I found here in the States that sell them. And I know ultimately these are all made in China, so at some regard to that, you're going to have to deal with China anyway. But when it comes to purchasing them, I'd rather purchase them from a more local supplier who has them in stock rather than waiting to get them from China directly. Now it's going to be cheaper obviously, but you still have that whole waiting time. And I could point out this particular one I have here and the USB model that I have on my desk I got relatively quickly, within a week I'd say, from a supplier here in the States, both of them, different suppliers. The Chinese model here, this buck boost converter, I couldn't find any suppliers, so I did get it directly from China, and it took me a month and a half almost to get. I mean, they were really cheap, less than $1 a piece, if I remember correctly. So with that, your mileage is going to vary. You may get them right away, depending on where you live in the world. It may take you a long time like it did for me. Maybe as they catch on a popularity, people will start carrying them here more in the States. But either way, I digress. The point of the video is how they work. And there is one very similar component between these all. And you will actually see that most of them have a microchip that controls the whole operation. And then they have these inductors, and you can see this one actually has 2 inductors. One of these is going to be for the step up portion, one of these is going to be the step down version. And if I bring in the other one here into view, you can actually see this little 470 here. This is the inductor. If I go back up to the large power supply, you can see that this one also has the same inductor, which is actually under this. And by the way, this is the control chip here. This one I like because it has a little heat sink on it that's just held on by some thermal compound. And I do intend on putting that same kind of a chip on the new buck boost converter that I have here, because it does get quite warm depending on what kind of current you're putting through it. Now, you notice that the other one I showed you initially had a push button display that you can use to set the voltage and the current to. This one unfortunately does not. You do need to use a multimeter, particularly the voltmeter part of it, and you use this little tiny trim pot here to adjust it. And it's very, I wouldn't say finicky, but it's very precise. You can actually turn it quite a bit of turns. It's a multi-turn little knob here, and that will allow you to set pretty much any voltage that you want on it. And what's really nice is like I mentioned, it doesn't matter if you're going up in voltage or down in voltage. Why would you use this? Well, a great example is you're trying to power a device from a battery, but the battery will drop down in voltage to a certain point. And if you're using, let's say, a linear power supply, you're using a like a 7805 linear regulator, and you're taking you know, a 12 volt battery, let's say, and converting it to 5 volt. What happens is there's a dropout voltage. Some of them it's like 2 volts beyond what the supply is going to put out. So in that situation, a 5 volt power supply will actually cut off after it gets below 7 volts input voltage. And well, obviously you get the idea. You still have more power you can put out from that device. You can actually, you know, kind of run it flat, if you will. So in that situation, you know, if you're using this kind of a supply, you can get lower than that input voltage, and it would actually boost the voltage up to meet the output voltage that you set. A car, for example, you know, has a wide range of voltages. You could use this in a situation in a car to get exactly, let's say, 12 volts out, even though you might be putting 11 volts in or 14 volts in, which is a good use for it. You can use it, let's say, to drive LEDs or different things like that. From my findings, and this is probably the right way that the thing works, it seems that when you start getting lower in voltage and it has to step it up, the current becomes greater. So if you're using a 9 volt battery and you're trying to get 12 volts out of it, you got to be careful that you don't exceed the current rating of the 12 volt battery, obviously, because you're never going to get the device powered. And one of the reasons how I came upon figuring this out, besides it probably being, you know, general knowledge, is on my benchtop supply here. You see there's a 3.3 volt rail that I actually hooked this up to and got 12 volts out of, which worked, but it drew more current than this little readout ended up, you know, using, and it actually killed the display. It just went blank. I still got the voltage out of it, but you know, it is a 14 amp power supply, and of course I didn't exceed that 14 amps, but that's just like a fluky kind of thing. Plus, you know, it could have something to do with the fact that this is a switched mode power supply that we're hooking another switched mode power supply into. I'm not entirely sure, but it was pretty interesting to see that happen. Also, I noticed it got really warm when I was trying to power whatever test device I was working on. So that is something to keep in mind. But then again, this USB one over here from usage, you know, charging my cell phone, got pretty warm too. And that was, you know, kind of to be expected, I guess, because you're, you know, reducing and increasing voltages and you're doing all this kind of back and forth stuff, so of course it would get warm. But what I'm going to do now is I'm actually going to pan out here a little bit, and I have my multimeter set up, and I'm going to show you exactly how you set this thing. I don't intend on this video being any longer. Actually, I've heard about these things, actually quite a few of these things, from Jillian's site, his YouTube channel. He's very informative, and he's really big on these power supply units as well. So if you want to learn more about these, then maybe I can explain, then I would check out his channel for sure. You know, like I said, he's a really good resource for these things. But when I heard about these things, I said, hey, that's a great idea and a really good piece of equipment to have in the lab, especially if you're, you know, a tweaker like I am. Now, I do have something I want to use this with, and they actually sell it on eBay as part of a kit, and the kit comes with a bridge rectifier. And what I want to do is I have a model train collection, specifically G-scale model trains, and one of the engines that I have is kind of a basic engine. It doesn't have any lighting to it, and I would like to actually use this particular driver to drive some LEDs, because in model railroading, a lot of the times the lighting is proportionate to the speed of the train, simply because the light is hooked up directly to the rails. The more juice you give the train, the faster it goes, and the light tends to get brighter. Some of the more modern ones have a stabilization circuit, I'll call it, that allows the light to remain at a constant, brightness despite the power to the rails. In fact, you can actually have the train crawling or barely even moving at all, and the lights will still light up. So I'm thinking, using this particular circuit with some LEDs, I should be actually able to do that. So I'm going to actually, I don't have any of that stuff here. It's actually in my parents' attic because it's just too much to store here in my house. So I'm going to grab some of that stuff one day, and we're going to experiment with it and see what we get out of it. But for now, I'm just putting some jumpers onto the corner of this board. You can actually probably see that there were 4 solder pads that allowed me to make connections to it. The USB power supply that I pointed out before also has the same solder connections you can see right here, and I wouldn't be surprised if they're not made by the same manufacturer. The one on my benchtop power supply, the green one with the adjustable LEDs, LCD, yeah, the LED screen, that one was made by a company that makes quite a bit of those different devices. They have step up, step down. I thought the step down one would be a little bit more useful for me, so I happened to pick up one of those, but who knows, maybe in the future I'll pick up one of the step up ones. But anyway, I'm kind of getting off topic here. I want to show you how to set this. So you can see I have my trusty fluke meter here. We'll put this onto volts DC. We can see right now it's set to 5.02 volts, and I have 11.7 volts coming in from my power supply here. And all I got to do is just set up one of my screwdrivers over here. You need a really small flathead. They actually make trimmer pot, adjustment tools. I don't have one of those, so I'm just going to go ahead and use the screwdriver. But if I get my arm out of the way, you can see we can go pretty much either way here. We can go up in voltage. Now I'll show you, actually, we can actually go way past that 11 volts if I want. Now keep in mind, like I said, it's 11.7 coming in. And you can see from turning the screwdriver, I'm doing this quite a bit. I'm going to stop right there just for ha-has. It's 11.47, but if you wanted to adjust this, you have to very slowly turn it. And you can get precisely whatever one you want. Now I'll switch this positive rail out, and I'll put it onto the 3.35 terminal, and you can see I'm still getting that 18.26 out of it. So getting 3.3 volts in and 18.26 out, that's pretty good to me. And that chip, it's not getting really hot, but it is getting kind of warm. And keep in mind, the only load on this thing is the voltmeter, so you can get an idea what I mean about it getting hot. There are quite a bit of uses for this thing, but if you're going to do anything serious with it, I do suggest getting a heatsink for it for sure. And we'll do the opposite here. We'll turn this thing way down. See, those trim pot tools have a little like cup dish at the end of it to keep it from slipping off. Oh, going the wrong way here. I think this goes up to 32 volts. I don't want to chance it because, believe it or not, the capacitors on this thing are only rated for 35 volts, which is kind of astonishing. You usually want to try to go with double what the output of the device is going to be, or double what the input is going to be. So there's a 35 volt one, 220, I'm assuming 220 microfarad, 35 volt on each side here, and this thing puts out higher voltages than that. So I wouldn't want to, you know, chance them and blow them out. Now I could actually go ahead and lower this down to useful voltage, like let's say 1.5 volts, and use this in place of a AA battery, for example. So now again, it's 3.35 coming in, 1.48 going out. You know, you want to use it for different things, like I said, maybe one of these flashlights. Sorry, like one of these, which takes a AAA battery. Maybe you want to power this off of a 9-volt battery. This is probably a really good way to do it. Current, though, is going to be the thing. There really isn't any way to limit current on this. I'm pretty sure, though, I did see ones that did. They just have a second trim pot next to it, and then you can use that to adjust the current. But again, you would need a multimeter to adjust that. Not a big deal. We can obviously set the Fluke multimeter and read amps or microamps. So we could theoretically do that. So I'm gonna maybe scour around and see if I can find one of those. But ultimately, if you're gonna do something with an LED, you're gonna use resistors anyway, just to limit the current. That's probably the easier way to do it. But you could, you know, drive directly an LED with this if you did have some kind of a current limit on it. Just so you can get the idea, there are quite a bit of uses for this little thing. This, you know, the train idea was just one of many different ones. I'm sure if you start looking around on the internet, you can find there's quite a bit. But the idea of being able to go up or down in voltage, depending on what the input voltage was, I thought was pretty sweet. So with that, I want to thank you for watching. There's really not much more to add to this video at this time. If I get a hold of the stuff I want to work on, I will actually, you know, have a whole complete separate video on that, as always. Again, if you're not already a subscriber, I really appreciate if you subscribe. I looked just a little while ago, and I'm getting very, very close to that 50 subscriber mark, which is halfway to my goal for 2016. And being that it's just about the end of February, and March is going to be, I think, Tuesday this week, that's pretty darn good to me. If you are already a subscriber, hey, thanks for sticking around. I really appreciate that, guys and girls. I understand from looking at the demographics, I have viewers from all over the world now, which just totally astonishes me. It just goes to show you how great YouTube is. But then again, I watched YouTubers from all around the world myself, and you know, this is a learning community. You know, I'm not the best guy when it comes to all this stuff because I'm not well versed in any one area. And in case you haven't really figured that out by now, I kind of get all over the map with things, but that's just the way my brain works. You know, I'm good with electrical, carpentry, plumbing, you know, now electronics I'm working on. I do mechanical stuff. I work on my own vehicles. So I'm always doing something somewhere with something, if that makes sense. And actually my day job has nothing to do with any of that stuff. Currently I'm working at a pharmacy as a purchasing manager. And everything that I know there, I've learned from working there. That wasn't my background. I don't have any medical background and stuff, but yet, you know, I learned quite a bit from doing that job. So, you know, anticipate on seeing a lot of different things in this channel coming up. Also, I've never actually mentioned it before in a video that I can remember, but I also have a Facebook page, and that's basically where the whole Pileggi technical thing resides for now. I don't have an actual website, but between the YouTube page and the Facebook page, I get quite a lot of information out there for you guys to check out. I do actually do some Facebook exclusive videos, you know, once again here and there I put them on there, depending on what I'm doing. So if you'd like to check that out, I'd really appreciate that. You can actually see in the description below, I'll have a link to that site as well. And I mentioned in an earlier video, when I did the car stereo stuff, that I'll be getting a new vehicle soon. Well, that vehicle should be in my hands tomorrow, actually. And by the time I get home and everything, it's going to be too dark to do any kind of a video review on it, but I will obviously have some updates on my Facebook page about it. So with that, I want you to stick around and grow with me. Thanks for watching.